Each of the 3 series of valves are designed to accommodate a specific flow rate. As I mentioned earlier on, we are required by the NFPA to have a discharge of 5 seconds to 10 seconds. Anything below or above those values is not considered a system that has passed the NFPA guidelines. Fortunately, Janice, with some of the experiences we had in previous years, we were able to implement a lot of our own ideas and thoughts on the design of the valve. So today, we have what is called a very low equivalent length of the actuation valve, which purely enhances the performance of the agent. Obviously, we're dealing in physics here with flows of liquids, so we have to ensure we can get enough agent to the nozzle in the hazard in those parameters. And with the very low equivalent length, it provides us with less resistance in the discharge piping and allows us to push the agent further, gives us a better coverage for the nozzle spacing and the types of nozzles that we have. This diagram here will show you the 2 conditions of the cylinder in operation. The one on your left is in the standby condition, where you can see that the piston is in the neck or the body of the cylinder and valve assembly. Once the system is called upon to actuate, venting takes place from the top of the electric actuator, which allows the piston to rise and the agent to discharge into the distribution piping. The SV series is the smaller of the 3 options available. As I mentioned earlier, we have the SV, the MV, and the LV. SV designates a small valve. MV designates a medium valve, and the LV designates a large valve. The SV comes in 3 particular arrangements. We show the minimum fill of, the minimum size of 40 pounds, the mid size of 80, and the larger of 130 pounds. And as you can see on the bottom, we show you the empty weight of each of the cylinders. Obviously, dimensions are important for the people doing the installation. So we obviously give them some idea of the size, the footprint, if you wish, of the cylinder, because every installation is different based on the client's hazard or room layout. When we talk of a cylinder assembly, it's basically the cylinder valve, the cylinder, and the dip tube. The cylinder valve controls the release of the agent. It is a differential pressure valve. I'm sure many of you are familiar with those. Forged body and cap. And by law, we are required to ship with an anti-recoil plug installed. This is to avoid an unfortunate discharge by mishandling. The dip tube extends from the cylinder neck down to the bottom of the cylinder. Once the system is called upon to actuate and the valve is open, the energy from the nitrogen forces the liquid up the discharge tube into the discharge piping. We recommend the cylinders be secured to the wall. We are able to provide cylinder brackets. Some people choose to supply their own. It's available from Janus also. The cylinders are a welded seam cylinder manufactured to DOT standards. We cannot ship cylinders over the road, out of the country, domestically, anywhere, unless they carry a DOT designation. DOT means Department of Transport. Perhaps you have something similar here in South America, but that is our Bible. We have to follow those regulations. Designed for vertical mounting only, these cannot be laid down, they have to stand upright. Here we show you a cutaway of the valve and the 6 various features that it has to offer. At the top of here we show you the valve actuation connection. This is where we would have the electric actuator on the primary cylinder, a single cylinder, or a pneumatic actuator where we have multiple cylinders. Each valve comes with a pressure gauge where you can monitor the pressure in the cylinder. And we also offer a supervisory pressure switch where should there be an increase or a decrease in pressure, you will have a signal back to your control panel to alert you of a potential situation that the cylinder needs to be addressed, refilled perhaps, recharged with nitrogen. There's a number of scenarios that would cause that. You heard me mention earlier on the trim components. Very simple in design. Basically, we have the electric actuator, and then we also provide the ability to actuate the cylinders manually, which requires the pulling of the pin and striking the plunger downwards to actuate the system. Each cylinder comes with a rupture disc. What that rupture disc does, it also allows for venting of that cylinder should the pressure exceed 850 psi. So there are redundant safety features incorporated into each of these systems. Here is the anti-recoil plug that I mentioned earlier on. Basic pipe unions and elbows are required to tie the cylinder into the discharge piping or manifold should you have multiple cylinders. One of the key features that we've managed to incorporate into the Janus system, if you see the top line there, we are able to discharge up to 15 slave cylinders from a single primary cylinder. Prior to Janus, we were restricted to 9 slave cylinders off of one primary. So with rigorous testing and achieving the right results with UL and FM, we could prove that we could fire up to 15 slaves. When I say fire, we mean discharge. And the single most important thing to understand, when we are facing just a 5-second or a 10-second discharge, when the primary cylinder is actuated, either electrically or manually, within 1 second, in this instance it's 5 cylinders, but if there were 15, every cylinder has to discharge within that 1 second and deliver the agent into the hazard within 5 and 10 seconds. We recommend the use of a discharge pressure switch, as you can see here on the left-hand side. This indicates that a system's been released, and it also allows the shutdown of any HVAC air conditioning units that may remove the agent out of the hazard area quicker, so we look to have those closed down. The piloting is a simple flex hose connection off of a actuation check valve. We'll get into some of the common components in a little while, but you'll see each of these has what we refer to as a check valve. What that does is this prevents any agent escaping from this outlet if this cylinder was removed from the manifold assembly. To avoid any additional buildup of pressure in the piping or the pilot line, we also provide a vent check just to bleed off any excess pressure until the reason can be verified as to why that's increased from the beginning. Here we have the check valve. This is the inch and a quarter. As I mentioned, it's required for multiple cylinder arrangements and also for connected main and reserve. Main and reserve is literally, you have a main bank of cylinders, which is your primary system for protection of your critical area. And then through the transfer switch, what we call the main and reserve switch, you transfer the electrical power to the secondary bank or reserve bank, which allows you to refill the primary bank, maintaining the integrity of the system and the protection that you're looking for in your hazard. This is the MV series. Comes in two particular sizes, 250 pounds, 420 pounds. Again, we show you the empty weight and the dimensions. You will see from the MV series and the next series, the LV, the system's a little different in its design. The MV and the LV incorporate a liquid level gauge. The smaller cylinders are manageable by muscle power to check the weight and the integrity of the system, if you wish, the amount of gas confirmed by the pressure reading on the pressure gauge. This allows you a redundant feature of avoiding taking out the cylinder to weigh it. We have a magnetic